Hi, I'm Ed Sperling. I'm the editor-in-chief of Semiconductor Engineering. I'm here with Dana McCarty from FlexLogic, who's going to talk today about the best benchmark for whatever you're trying to do. So Dana, there's lots of benchmarks out there. There's a lot of confusion. And at the edge, which is this undeveloped area still developing because it just takes too long to move signals back and forth between the edge devices and the cloud, we've got all these different compute models that are starting to develop here. How do you know which is the best benchmark?
Ed, you ask a great question, and I agree. As the market's evolving, we're seeing customers trying to figure out how they get approximations or how they gauge the performance of hardware and software solutions. So that's one of the things we wanted to talk about.
Is this a continuation of domain-specific types of designs?
Yes, Ed, it is. What we're seeing is with domain-specific models like YOLO V3, as customers mature, they're seeing that it doesn't give them a good enough approximation on the performance in their applications. So they want to go one step further and use their actual models to be able to judge the performance of hardware and of AI inferencing solutions.
So let's dig into this.
Sure.
Dana, what are we looking at here?
So Ed, what we're looking at is the progression that we've seen in customers of how they evaluate hardware and software performances to be able to get closer approximations to their actual applications. So what we've seen is the first step is the specifications. And people are seeing this now. The specifications are basically TOPS, which people know is the max times frequency. This is misleading. It shows raw horsepower, but it doesn't take into account the software or the type of model that they're using. The other thing we found is TOPS isn't standardized. It can be multiply or it can be multiply and accumulate. It's hard for customers to be able to translate this to valuable results on their model. The other main disadvantage is it doesn't show bottlenecks with I/O. With really efficient hardware, or I'll say solutions because it's hardware and software, it's a good combination of the right amount of compute with the right amount of I/O.
So this can be as complicated as you have two basically similar types of specifications, designs, but they get used differently depending upon the application, right? So one may be more heavily using memory, another one may be doing the processing more, and you may have bottlenecks that erupt depending upon that use model.
Exactly. Some models will have more I/O, some models will have bigger weights as they come in, and that creates bottlenecks when you're trying to do that I/O exchange. Yes, Ed.
So how do you drill down to that level? You think about a cell phone, for example, they normally test against what, 60 to 80,000 possible use cases.
Correct. What we've seen is customers are moving from the specifications to now the micro benchmarks.
So this goes back to more than just the basic design, right? Because you may have a design that's used for two completely different applications, even though it's exactly the same design. One may leverage the memory, one may leverage the I/O differently, and each one has its own use case.
Correct. Models can be very different. Even when you're doing object detection, models can be very different. So it's difficult to be able to easily translate to the performance of the solution.
So where do we go next for this?
It's a good question, Ed. What we look at is the progression of being able to get to benchmark the actual application. And the next step is what we call micro benchmarks. And in that, customers are looking at individual convolution layers. The reason this is better is instead of just raw MAC operations, now you're in the domain of machine learning. You're doing matrix multiplication, you're looking at individual convolution layers. TOPS are just pure operations where now you're using instructions. You're able to look at least at a simple level at the data flow, at compute flow, at arrays and how they're formed. And so this moves in the right direction, but it doesn't give a customer useful information yet. It's algorithmically aware, but the output is not useful.
So what you're heading for here is more granularity in how this stuff is actually getting used and what sort of problems you'll run into along the way, right?
Yes, there's so many variables. And as the market's emerging, it's being able to figure out how those variables impact the performance in the actual application.
We're used to using models here in order to be able to identify exactly how things are going to be developed as well as used. A lot of times those models don't exist. What do you do in that case?
What we're seeing customers do is taking off the shelf models to be able to, as I said earlier, get a closer approximation to the actual application. So models like YOLO v3 or VGG, ResNet, Inception, different types of kind of standard models. The advantages of these are kind of threefold. One, they're standardized. YOLO v3 is standard model. It gives you a higher level of extrapolation to the performance as you go down into the layers. And third, it gives you now pure throughput, recognizable results like frames per second. It can give you power throughput numbers. So it's giving you recognizable data relevant to the actual application. The issue though that we're seeing is no customer is implementing standard off-the-shelf models. They're taking models like, let's say YOLO v3, but then they're making changes to those models. And now they're trying to extrapolate out, okay, with these changes, how do I again approximate the performance of my application?
So you've got different use models, you've got different heterogeneous designs where people are putting together different things in a solution and a system. And you've also got different market applications for all this stuff. All of these are trying to fit together and they don't necessarily work with what's out there, right?
Correct, correct. And that's why we're recommending that customers go, and if they're trying to benchmark to a solution, that they put their models on that solution. It gets them the closest to the actual application, and they're able to now have very recognizable results, or results as far as throughput, power to the application, which is what they're specifying.
So a lot of these designs are heterogeneous. They're used differently. The markets and markets that they're used in are different. So each one of these has its own unique needs that are not necessarily standardized. How do you apply all this stuff? Because the pieces don't necessarily fit together at that level.
We don't typically see customers using standard off-the-shelf models. They do their own models. And this is why we recommend that customers take their models and benchmark them on the inference solution that they're looking for. Now you're able to clearly assess IO inputs, or you're able to assess compute power, and you're able to more accurately get to the performance estimates or the performance specs that you want in your actual application. There's still other variables, like, when you're in a system, that there's different memory types and things like this, but it will get a customer closer to the actual application.
In the past, when people looked at benchmarks, they typically didn't really think about, oh, this is going to be specific for my application. It's typically, this is the off-the-shelf part, this is the off-the-shelf benchmark, and here's the general idea of how this is going to get used. A lot's changed since then. Are those previous benchmarks still going to be useful, or is it now all going to come down to everybody's going to have to develop their own custom models for a specific benchmark?
So what we're seeing, the magic in the solution is the models. Customers, that's their IP, and that's how they differentiate. So I think what customers are trying to do is take some level of standard benchmarks to be able to extrapolate to get to an area where they can judge or approximate what the performance is going to be. But to really get closer to be able than just a broad approximation, is they should take their models and run them on the inference AI solution, and be able to judge their own performance.
Does this put more of a burden on the customers to actually do more of this work themselves? In the past, they pretty much took an off-the-shelf benchmark. They can't do that anymore, right?
Correct. It's putting a lot more burden on the customer, because as we talked about, because of all the variables, it's becoming very difficult to predict that the level of performance that they will need to, as they specify in their application. So they've got to be able to, as they're building out their system and picking the right solutions, that they pick the right solutions to get to the end performance of the application that they need.
Dana McCarty, thanks for a great explanation.
Thanks for your time, Ed.